Here's something worth thinking about as you settle in tonight. The most powerful thing humanity has ever built keeps finding things in deep space that should not exist. It's called the James Webb Space Telescope, a mirror of real gold floating 1,000,000 miles from your bed. And through it, we're seeing things we could never have imagined, things we thought were impossible. Galaxies as large and settled as our own, finished before anything had time to grow. Hundreds of small, deep red lights that match nothing in any book on Earth. Black holes heavier than 1,000,000 suns, blazing in the universe's first mornings. Tonight, we'll go out to the gold mirror and look through it together, one impossible thing at a time. If you enjoy falling asleep to mysteries that the smartest people alive can't explain yet, do me a small favor and hit that subscribe button. It genuinely helps this channel grow and lets me keep making these deep dives for you. Also, tell me in the comments where in the world you're falling asleep tonight. For now, dim the lights and settle in. Let your shoulders come down and your jaw unclench, because tonight all the watching will be done for us by a machine 1,000,000 miles away that holds perfectly still, so nothing down here has to. The covers are heavy. You're off duty. Have you ever wondered why the Great Mirror is coated in real gold? And why all of it together weighs less than a golf ball? Why the coldest machine our species ever launched hides behind 5 silver sails the size of a tennis court? Why looking farther into the dark always means looking further back in time? And why the trick works from your bedroom window too? What appeared when astronomers pointed a telescope at the emptiest scrap of sky they could find? For 10 days straight, how hundreds of worlds drift through a nursery of stars with no sun at all, some in pairs, holding on to each other. And the strangest one of all, when the universe is caught doing something the books call impossible, which one is wrong, the universe or the books? People have stood at that crossroads before, and every time the answer changed everything. That road begins tonight, with one golden eye opening on a small scrap of dark. Let's begin. Start with what the telescope actually does all day, because almost nobody pictures it right. It doesn't sweep the sky. It doesn't hurry from wonder to wonder. Mostly, it stares. Somewhere out in the dark right now, it has chosen one small scrap of sky, often a scrap that looks completely empty, blacker than the space between the stars over your roof. And it holds its gaze there, not for seconds, not for minutes, for hours, and sometimes for days on end, motionless, silent, patient, beyond anything a living eye could manage. It's the stillest thing our species has ever made. While it stares, the light arrives, and you should picture how little of it there is. From the farthest galaxies, the light comes in as single travelers, one small packet at a time, a faint tick here, a faint tick there, sometimes seconds of nothing in between. Think of it like setting a bucket out in the slowest rain there has ever been. One drop, a long quiet. Another drop. No single drop tells you anything at all. But the bucket doesn't get bored, and it doesn't blink, and drop by drop, over the hours, something gathers. And how still is still for a stare like that? Stiller than anything you've ever touched. At these distances, the smallest tremble smears a galaxy into a streak, so the telescope has to hold its aim the way you'd hold a laser dot steady on a coin from 200 miles away and hold it there for days. It can't use thrusters to steady itself. Thrusters shudder, and their exhaust would mist the precious mirrors. Instead, deep in its body, a set of spinning wheels lean gently one way and another, trading their spin for stillness, making corrections finer than the width of a hair seen from across a valley. Some of the instruments even take turns working, because a few of their little motors tick when they move, and at this scale a tick is an earthquake. Here's a comparison to fall asleep on. Your bedroom, right now, is trembling more than the telescope is. Your floor hums faintly with distant traffic. Your walls flex a little with the wind, The quietest room you have ever stood in is, by Webb standards, a rowdy place. Out at its balance point, in the endless calm, the golden eye has found the stillest spot our species has ever occupied, and it spends every bit of that stillness on one thing, listening to the past, without fidgeting, and then the something becomes a picture, and the picture is never, ever empty. That scrap of black, the one that looked like a gap between the stars, comes back crowded. Thousands of galaxies, in one frame, in a patch of sky you could cover with a grain of sand held out at arm's length. Every smudge in the picture is a city of stars. Hundreds of billions of suns. Each one with its own worlds, its own weather, its own long nights. Some of the smudges are golden spirals. Some are soft white clouds. And some, the small ones, the faint ones, are little points of deep red, like embers at the bottom of a fire. Those red ones are the reason for tonight. Because in a picture like this, distance and time are the same thing, and the redder and fainter a galaxy sits, the further back in time you're seeing it. A deep field photograph isn't really a picture of space. It's a family album of the whole universe, with the recent generations up front, and the very first pages, the baby pictures, buried at the faint red bottom of the stack. So astronomers did what you'd do with any album. They turned to the earliest pages first. The deepest, reddest, oldest points of light in those first frames should have been small and half-formed. The universe was only a few 100 million years old back then, barely out of its first dawn, and the books are clear about what belongs there. Seeds, sparks, little gatherings of new stars. Faint and messy and just beginning. That's what everyone expected, and that's not what came back. Some of those first-page galaxies came back looking grown. Big, bright, orderly, heavy with stars, calm in a way that takes ages to achieve. It was like opening a family album to the very first page, the hospital pictures, and finding a photograph of a woman of 40, smiling, settled, with laugh lines. Nobody laughed at the time. One astronomer, scrolling through the first data on a laptop, found 6 of those impossible little red points in a single week, and the people checking the files started calling them universe breakers. Not because the universe was broken, because the books were. Something in those pictures had no business existing, and it sat there anyway, quietly, in frame after frame, refusing to be a mistake. Hold that feeling for a second, because it's rarer than you might think. Have you ever been completely, delightfully wrong about something you were sure of, not embarrassed wrong? The other kind, where the world turns out to be bigger than your version of it, and you can feel your map being redrawn while you stand there. That's the feeling that moved through astronomy in those first months, and it's the feeling this whole night lives in, because you have to understand what those scientists had to lose. The story of the universe, the one being tested in those frames, isn't a guess. It's the most successful story our species has ever told. Checked against the sky 10,000 ways. Correct about almost everything, almost everywhere, from the afterglow of the beginning to the weights of the atoms in your hands. When a story that good starts failing, quietly, on its very first pages, the people who love it best are the ones who feel it most. And here's what they did, which tells you everything about them. They didn't hide the pictures. They published them, argued about them in public, named them impossible in their own journals, and pointed the telescope right back at the problem. Science keeps its treasures in a strange vault, the one marked wrong. Every impossible thing tonight is in that vault, gleaming. So, as we go deeper, you're not walking through a museum of settled facts. You're being handed the actual unsolved things, as they stand this year, still warm from the argument. Very few generations get to watch their universe's story bend. Yours is one of them, and you get to watch it from bed. Now, before you can feel just how wrong those pictures are, You need to meet the machine that took them, because the machine is half the story. Nothing about it is ordinary. It's the most expensive scientific instrument ever built, the work of thousands of people across 3 decades, and most of the engineers who started it had gone grey by the time it flew. The heart of it is the mirror, and the mirror doesn't look like a telescope at all. It looks like a golden honeycomb. 18 six-sided tiles fitted together into one great dish, taller than your house, gleaming like something out of a treasure story. The gold is real, and the gold is the point. Gold is the finest mirror there is for the kind of light this telescope hunts, the stretched, reddened, heat-colored light of the early universe. And here's the detail worth keeping. The golden coat is thinner than the wall of a soap bubble. If you scraped every atom of it off all 18 tiles and pressed it into a lump, you'd be holding about the weight of a golf ball. That's the whole treasure. A golf ball of gold, spread over a dish the size of a climbing wall, polished so smoothly that if the mirror were as wide as a country, its tallest bump would be ankle-high. Under the gold, the tiles are carved from a metal so light and stiff that engineers use it for the bones of instruments, and each tile can flex and tilt on tiny motors, in steps far finer than a human hair, so the 18 act as one perfect eye. And that eye had a problem. It was too big for any rocket ever built. So they folded it. The whole telescope, mirror, instruments, everything, was designed to fold up like a ship in a bottle, wings tucked, sails rolled, and to unfold itself in space, alone, 1,000,000 miles beyond any hope of a helping hand. Below the mirror hangs the other marvel. The sun shield, 5 separate sails of silvery foil, each one thinner than a human hair, spread wider than a tennis court. Their job is shade. Layer by layer, they peel away the sun's heat, until the hot side of the telescope bakes hotter than any desert noon, while the cold side, an arm's length away, settles colder than any night ever recorded on Earth. If you wanted to buy that shade in a shop, you'd be asking for sun cream, with a protection factor of about 1,000,000. It launched, after decades of delays, on a Christmas morning from a jungle spaceport on the northern coast of South America. And then came the part the engineers still don't enjoy remembering, the unfolding. Over 2 weeks of flight, the folded machine had to open itself, step by step, hinge by hinge, cable by cable. Counted honestly, there were 344 separate steps that each had to work, and most of them had no second chance. One snagged cable, one stuck pin, and the whole golden eye would have flown on forever as the most expensive piece of luggage in history. The people who built it describe that fortnight as a month of held breath compressed into 14 days. And every single step worked. The sails spread. The honeycomb clicked open. A month after launch, the telescope glided into its parking place, a quiet balancing point 1,000,000 miles out, 4 times farther than the moon, where the pulls of sun and earth agree, and where sun, earth, and moon all stay conveniently behind its back, forever. It will never come home. It wasn't built to. It went out the one-way door we spent another night talking about. And it took the door gladly, because out there in the cold and the dark is the only place its work can be done. The road to that launch pad, by the way, took a whole working lifetime, and the people who walked it deserve a minute of tonight. The telescope was first sketched before its famous predecessor had even left the ground, and it carries the name of James Webb, the administrator who ran the American Space Agency through the years it learned to reach the moon. Between the sketch and the launch stretched 3 decades of setbacks, redesigns, and patience. And some of the tests along the way turned into legends of their own. To prove the finished telescope could survive its working conditions, engineers sealed it inside a giant vacuum chamber in Texas, a steel room the size of a building, and chilled it down to the cold of deep space for weeks on end. And while it sat in there, Silent and freezing, a hurricane came ashore and flooded the city around it. Roads went underwater. Engineers slept in the building, took shifts on the pumps, and kept the great chamber running through the whole storm. Inside, the telescope never noticed a thing. It hung in its manufactured winter, being tested by one planet while being prepared for the calm beyond all planets, and the people wading to work through a drowned city kept its cold unbroken. When you hear that the telescope works flawlessly, that's what flawless was built from. Not luck, shifts, and there's a lovely epilogue to the launch itself. The European rocket that carried the telescope flew its course so precisely, so close to the perfect line, that the telescope barely had to spend its own fuel correcting the path afterward. Fuel is life out there. Every drop saved is future stargazing, and the savings from that one immaculate launch roughly doubled the telescope's working years. A machine designed to last a decade now carries breathing room measured in decades. A whole extra career gifted to it in the first half hour of its life by a rocket team that will spend forever quietly proud of it. And the eye needed one more thing before it could open properly. 18 mirrors are not one mirror. In the first weeks, when the telescope photographed its first test star, it saw 18 of them, 18 blurry copies scattered across the frame, one per golden tile. Then, over 3 slow months, tiny motors behind each tile, moving in steps of a few billionths of a meter, walked those 18 reflections across the sky and folded them into one. The day the last adjustment landed, the 18 stars became a single, perfect star, crowned with sharp rays, focused beyond specification, and in the background of that routine test photograph, behind the one chosen star, uninvited, the frame was already crowded with galaxies. Hundreds of them, photobombing an eye exam. That was the moment the teams knew exactly what they had built. Life at the balance point has its own weather, by the way, and its own small scars. The telescope doesn't sit parked at the quiet spot so much as circle it, tracing a wide, lazy loop around the empty point every 6 months, the way a moth circles a porch light that isn't there. Every few weeks it sips a whisper of fuel to stay on the loop, and those sips are the only spending it does. And the deep isn't perfectly gentle. Even out there, space carries dust, and dust at orbital speed bites. In its very first months, one sand grain of a micrometeoroid found one golden tile and struck it hard enough to leave a permanent little scar, a flaw the size of nothing, pressed forever into the perfect honeycomb. You might expect that to be a small disaster. It barely registered. The engineers measured the dent, nudged the tile's motors a hair, folded the flaw into the focus maps, and the eye went on seeing beautifully, the way your own eyes do despite their floaters and their years. It was a useful moment, in its way. It reminded everyone that the telescope isn't a diagram. It's a thing, out in the actual dark, taking the actual weather of space on its face, aging like everything ages, and doing its finest work anyway. The plan holds through the coming decades. The gold will dim a little, the scar count will grow, the staring will not stop. The answer is one of the loveliest ideas in all of science, and it fits in a bedroom. Look across the room at your lamp, if one's still on. You're not seeing the lamp as it is. You're seeing it as it was a tiny sliver of a moment ago, because its light, fast as it is, still needed time to cross the room to your eyes. Light is quick, but it isn't instant. Nothing you have ever seen is now. Everything you have ever seen is history, usually by a whisper, sometimes by more. Moonlight over your roof left the moon more than a second ago. Sunlight on your curtains in the morning is 8 minutes old when it arrives, a small bulletin from the recent past. The light of the nearest bright stars set out years before you noticed it, some of it before you were born. Keep going, and it gets serious. There are stars in your night sky whose light left them before there were pyramids. Point a good telescope at the right smudge, and you catch light older than Earth itself. Looking far has always meant looking back. Every telescope is a time machine with one strict rule. It can only look, it can't visit, it can't touch, it can't warn anybody. It just receives the old light, the way you'd receive a letter from someone long gone, and reads, "Would you like to know the oldest light your own eyes have ever caught?" There's a good chance it's this. On a truly dark autumn night, away from the streetlights, people with sharp eyes can just make out a faint elongated smudge in the constellation of Andromeda, like a breath on glass. That smudge is the nearest great galaxy to our own, an entire city of 1,000,000,000,000 suns, and its light spends 2.5 million years crossing the dark to reach you. When those photons left home, there were no humans yet. Our ancestors were small and careful and lived in trees, and the light was already on its way, and it ended its journey some clear night on the back of your eye. You've probably time-traveled 2.5 million years with your bare eyes and never known it. Astronomers measure these distances in light years, which sounds technical and is actually tender. A light year is simply how far light walks in a year, and it means every distance is also an age. The moon sits a second and a bit away. The sun, 8 minutes. The nearest star, 4 years. Andromeda, 2.5 million. And Webb's little red galaxies sit more than 13 billion light-years down that same road, which is the whole trick of tonight in one sentence. There's no wall between you squinting at Andromeda and Webb reading the dawn. It's one single skill, catching old light, and your species recently got very, very good at it. But the universe does one more thing to those oldest letters. And this is the part that shaped the whole telescope. The universe is growing. The deep stretches of space between the galaxies are slowly widening, and they have been since the beginning. And light that travels through a growing space gets gently stretched along with it, like a note drawn on a balloon as the balloon inflates. Stretch light and you change its color. Blue stretches toward red. Red stretches past the edge of what your eyes can do, out into a kind of light you can't see at all but already know by another name. Warmth. The glow of a stove after it's switched off. The heat you feel from a sleeping dog without touching it, that invisible warm glow is simply light too stretched for your eyes. And it's the language the early universe speaks now. The first starlight ever made set out white and fierce. And after more than 13 billion years of travel through a growing universe, it arrives at our doorstep, stretched into faint, quiet heat. So an eye for the first pages has to be an eye for warmth. That's why the gold, which reflects heat-colored light almost perfectly, and that's why the cold, because a warm telescope glows in exactly the light it's trying to collect. Point a warm telescope at the early universe and all it will ever see is itself. Like trying to spot fireflies across a field while holding a lit torch against your cheek. Chill the eye down near the coldest anything can be, and the fireflies come out. 13 billion years of history, hanging in the dark, waiting to be read by anything cold enough to listen. Here's the story of how anyone found out that invisible warm light exists at all, because it's one of the sweetest accidents in science. More than 2 centuries ago, the astronomer William Herschel, the same man who had discovered the planet Uranus from his back garden, was doing a simple experiment with sunlight. He split a sunbeam through a prism into a rainbow on his table and set little thermometers in the colors, one in the blue, one in the yellow, one in the red, to see which color carried the most warmth. As a control, he laid one more thermometer just past the red end, outside the rainbow, in what looked like plain shade. That one, the one in the nothing, red hottest of all, he checked it, and moved it, and checked again, and then understood. Sunlight didn't end where his eyes said it ended. There was more rainbow past the red, invisible, pouring warmth onto his table. He'd discovered a whole hidden kingdom of light, with a thermometer in the shade. That kingdom is where you live more than you know. Your own body glows in it, brightly, all night long. Snakes hunt by it. Your remote control chatters in it. And it's the language the infant universe speaks now, which is why our finest eye for the deep past is really a thermometer of magnificent breeding, sensing warmth so faint it has no business being sensible. The engineers like to say Webb could detect the heat of a single bumblebee at the distance of the moon. That's the instrument. A bee, a moon away, and it would notice. One more reason the eye had to leave home entirely, and then you'll own the whole design. Our sky is in the way. The air over your roof drinks most warm-coloured light before it reaches the ground, and what's worse, the air itself glows warm all night, everywhere. Trying to see the universe's faint warmth from down here is like trying to stargaze from inside a lit greenhouse with fogged glass. So the eye went above the air, and then it went far beyond it, because Earth itself glows, and the moon glows, and every warm thing in the neighborhood is a lit torch beside the cheek. 1,000,000 miles out, hidden behind its 5 silver sails, with sun and earth and moon all parked behind its back. The telescope finally hangs in the one kind of darkness that matters to it. Not just dark to your eyes, dark to a thermometer. Cold, still, silent in every color it can hear. That's the whole machine, really. The most elaborate quiet ever engineered, which brings us to the bravest decision in the history of pointing telescopes, and it happened a generation ago on the older space telescope, the famous one named for the astronomer Edwin Hubble. By the middle of the 90s, it was the most in-demand scientific instrument on or off the planet. Every hour of its time was fought over. Waiting lists ran years deep, and the person in charge of it, the director, held a small personal allowance of observing time to spend however he judged best. He announced he would spend 10 straight days of it photographing nothing. He chose a patch of sky near the handle of the plough, picked precisely because it was empty. No bright stars, no known galaxies, no anything, a keyhole of plain darkness about the size of a grain of sand held at arm's length. Colleagues told him, in polite academic language, that he was about to waste the most precious machine alive, that the picture would come back blank, and that careers had ended over less. He thought the risk was the point. If you only ever look where you know there's something, you'll only ever find what you already know. So over 10 days around Christmas, the telescope stared at nothing, and the bucket sat out in the slow rain of light, and the drops fell. One by one, 342 exposures gathered into one frame. The frame came back holding about 3,000 galaxies. In the empty patch. In the keyhole, 3,000 cities of stars, stacked behind one another into the deep spirals and clouds and collisions, golden and blue and faint red, all of it hiding inside a scrap of black that every eye in history had looked straight through. That one photograph, the deep field, quietly rearranged our species' picture of the night. It meant there is no empty sky. It meant every dark gap between the stars over your roof tonight is a curtain, and behind it stand thousands of cities of suns, and behind them thousands more, all the way down, and it meant something even better. It meant that the dark was worth staring at, that patience itself was an instrument, and that the universe rewards whoever holds still the longest. Webb was designed by people raised on that photograph. So when the golden eye finally opened, one of the first things it did was repeat the gamble with sharper senses. It stared into its own keyholes of nothing, deeper than any machine before it. One summer evening, its first deep field was shown to the world. A patch of sky the size of that same grain of sand, crowded corner to corner with galaxies, some of their light older than almost anything ever photographed. The bucket had caught drops that fell before Earth existed, And near the faint red bottom of that stack, and of every deep stack since, sat the little points nobody could explain. The too big, too bright, too finished things, waiting on the first pages of the album. The empty sky had one more lesson in it. The past was full, and the past was wrong. And what does deepest actually mean when astronomers say Webb's deep fields are the deepest pictures ever taken? It means faint, to a degree that's genuinely hard to say out loud. The faintest smudges in those frames shine about 10 billion times fainter than the faintest star your eye can catch from a dark field. 10 billion. If your eye is a bucket catching rain, Webb's deep stare is a lake, held open for weeks, missing nothing. Some of the great deep programs stack, stare upon stare, on the same small patches. Visits woven together across months, exposures quilted into mosaics, until the total gaze on one keyhole of sky adds up to weeks of unblinking attention. Every return visit sinks the frame a little deeper, and every new depth is a new earliest hour of the morning. That's the machine astronomy has become while nobody was watching, patience industrialized. And there's a quiet human truth stitched into every one of those frames. Nobody alive can point to the deep field's galaxies out a window. Every single one was found by choosing to believe that more would be there if we only looked harder, and then looking harder. The universe has rewarded that exact bet every time it has ever been placed, without a single exception in the whole history of telescopes. Look longer, find more. It's the most reliable law in the business, and, held up against a dark bedroom ceiling, it's not a bad law to live under either. Before we open those pages, give yourself a moment with what the deep fields mean for your own window, because it's one of the finest bedtime facts there is. Add up every deep stare ever taken, and the estimates land in the same breathtaking country. The observable universe holds something like a couple of trillion galaxies. Trillions of cities of stars. Which means the handful of stars you can see from your street, the few dozen that survive the streetlights, are the thinnest possible foreground. A few fireflies on the glass of an infinite window. Hold up a grain of sand at arm's length tonight, anywhere in the sky you like. Over the rooftops. Between two stars. It doesn't matter. Behind that grain, from every spot you can choose, stand thousands of galaxies, stacked into the deep, every single one of them home to hundreds of billions of suns. There is no direction you can point where that isn't true. The sky isn't a ceiling with lights on it. It's an ocean, seen from the beach at night, and the deep fields were the first time our species waded out past its ankles. You don't have to do anything with this fact. It asks nothing. It just stands there being true while you fall asleep. Which is, if you think about it, exactly what it's been doing all along. So let's meet the universe breakers properly, because they've earned the introduction. First, you should know how astronomers tell how far away a galaxy is, since the whole mystery hangs on it. You can't pace it out. What you do is take the galaxy's faint light and spread it into a rainbow. Every element, hydrogen, oxygen, carbon, leaves sharp little lines in that rainbow, always at the same places, like notches on a ruler. It's a barcode, and every galaxy in the sky carries one. Now remember the stretch. As the light crosses the growing universe, the whole barcode slides toward the red, notches and all. And the amount of slide tells you exactly how long the light has been traveling. Read the slide, and you've read the date on the letter. It's honest, it's precise, and it doesn't care what anybody hoped to find. When Webb's first deep frames came in, the red little points at the bottom of the stack got their barcodes read one by one. And the dates were real. Some of that light had set out when the universe was younger than 300 million years old. That sounds ancient, and it's the opposite. It's infancy. If you squeezed the universe's whole life into a single year, with the beginning on the 1st of January, that light left in the first days of the year. The album pages were genuine. These really were the baby pictures. And the things in the pictures didn't look like babies. Some were startlingly bright, pouring out the light of billions of suns. Some were already tidy, with the settled shapes that come from long, calm lives. And when astronomers weighed them, using their light, the way a doctor reads a scale, a few came out heavy, not slightly heavy. Some early measurements suggested as much stuff in stars as our whole Milky Way carries today, and our galaxy has had nearly 14 billion years to gather itself. These had managed it in a few 100 million. Here's the problem. In kitchen terms, galaxies grow the way bread rises. Gravity gathers gas, slowly, patiently. And the books say how fast the dough can possibly rise, even with everything going perfectly. These loaves were fully baked before the oven had warmed up. A toddler in the hospital album with a full beard, an oak thick as a barrel, in a field where the acorns went in last spring. And before the checking starts, let yourself stand inside one for a moment, because it's a gorgeous place to imagine from bed. What would the night sky look like in a grown galaxy of the first days? Nothing like yours. The whole system is smaller and fiercer, the gas rich and everywhere, the star-making running hot. Overhead, instead of your calm scatter of quiet white points, the sky would be crowded with young blue suns, burning close and bright, and between them, in every direction, the luminous weather of birth, sheets and knots of glowing cloud, lit from inside, the whole heavens looking less like a ceiling and more like a storm season. New stars, igniting often enough to notice. The bright, dying flashes of the giant ones, often enough to expect. A sky with no old stars in it at all, because nothing, anywhere, is old yet. Your sky tonight is the settled version, the embers of that one, and the grown galaxies on the first pages had skies like festivals. That's what was sitting on the universe's first pages, claiming to be real. Now for what happened when people saw it. When the first of these showed up on that laptop, 6 of them in one small patch, the astronomer who found them said the data looked so wrong he assumed the files were broken. The files were fine. He and his colleagues checked for every boring explanation first, because that's the job. Then the paper came out, and the word impossible started appearing, carefully, in places that never use it. And while those 6 were being argued over, the record book was quietly catching fire. How early is too early for a galaxy? Before Webb, the oldest confirmed galaxy known had been found by the older telescope straining at its absolute limit. A little smudge from about 400 million years after the beginning, and plenty of careful people suspected that was close to the edge of what existed. Webb broke that record in its first months. Then it broke its own record. Then it did it again. The current champion, confirmed by barcode, was shining before the universe was 300 million years old. And here's the detail that keeps everyone up at night, in the best way. Each new record holder should, by rights, be fainter and punier than the last. A dimmer ember from a thinner age. They're not. The deepest galaxies keep turning up bright, busy, and bafflingly large. Several times more luminous than the models painted for that hour of the morning. It's as if the further back the telescope reaches, the harder the universe seems to be working. To build such things on schedule, the infant universe had to turn its gas into stars with an eagerness nothing alive today can match. In the calmest galaxies now, a nursery cloud turns a few parts in 100 of itself into stars before the rest blows away. The first pages seem to have managed many times that, gathering and igniting with a hunger the books never allowed for. Either the rules of star-making were different when everything was young, dense, and close, or something is wrong with how we read the dawn. The champions keep coming, the argument keeps sharpening, and the eye keeps staring. You might be wondering how anyone weighs a galaxy from 13 billion light-years away, and you deserve the honest answer. Because the whole controversy runs through it. There's no scale. What there is light. Stars of a given kind shine with a known brightness. So you measure all the light a galaxy sends. Assume a normal mix of big stars and small ones, and work backward to how much star stuff it takes to shine like that. It's the same skill as glancing at a town from an airplane at night and guessing its population from the glow. Sensible, powerful, and full of soft spots. If the town is holding a festival, the glow lies. If a galaxy's mix runs strange, or a feeding black hole blazes in its middle, the glow lies too, and the scale reads heavy. That's exactly the trap some of the first monsters turned out to be sitting in, which is why the field checked so hard before believing anything. But the checking cuts both ways, and here's the part that gets lost in the corrections. The glow can also lie light. If the first galaxies ran to giant stars, a little star stuff shines like a lot, and the weights come down. Fine, except giant stars burn out in a blink, which makes the bright, grown look of these galaxies even harder to sustain, and the puzzle pops up again, wearing different clothes. Every escape hatch anyone opens leads back into the same room. The early universe was busier than it was supposed to be. The only argument left is about which rule it broke to manage it. While we're this far back, get your bearings with the loveliest clock in astronomy, because it makes the whole album graspable from bed. Squeeze the universe's entire life into one calendar year. The beginning is midnight on the 1st of January, and this very evening, with you under your covers, is midnight at the end of the last day of December. On that calendar, the impossible galaxies Webb keeps finding are shining in the first week of January. The little red dots switch on and burn out before the month is done. Our own Milky Way assembles itself through the late winter and spring. The sun doesn't ignite until the very end of August, and Earth cools and gathers its oceans through early September. Life shows up in the middle of that same month, astonishingly promptly, and then spends nearly 3 months being gloriously unhurried, single cells perfecting themselves while whole galactic seasons turn. Fish arrive in mid-December. Dinosaurs walk on Christmas and are gone by the day after. And everything human, the caves and the campfires, the pyramids and the songs, the telescope and this voice and your bed, all of it happens in the final few seconds before the year ends. Every impossible thing in tonight's episode lives in the first days of January, seen from the last seconds of December, across the whole width of the year. That's what Webb actually does. It stands in the New Year's fireworks, looking back at the year's first quiet morning, reading the light that's been travelling since. Now, science did what science does, and you should hear this part too, because it's the honest middle of the story. Everybody attacked the result, which is a compliment in astronomy. Maybe the distances were wrong. Sometimes a nearby dusty galaxy can blush red and fake an ancient barcode. And when the real barcodes were red, a few of the monsters did turn out to be imposters, closer and smaller than they'd seemed. Maybe the weighing was wrong. You weigh a galaxy by assuming its light comes from ordinary families of stars, and if a hidden black hole is blazing away in there, the scale lies heavy. That turned out true for some of them as well. So the first headlines softened, the way first headlines should. But here's the thing. When all the checking settled, the puzzle didn't vanish. It shrank, and then it stood still. Even with every correction applied, the early universe holds far too many bright, busy, grown-up galaxies too soon. The record holders kept falling, each new deepest galaxy older than the last, and the brightest of them shine several times harder than the recipe allows. To make them, the infant universe had to turn gas into stars with a hunger nothing in today's sky comes close to. Either the first cities of stars were built by rules we've never watched in action, or our clock of the early universe is somehow off. Both answers are enormous. Nobody knows which one is true, And while everyone argued about the grown-ups, a stranger thing was sitting in the same pictures, politely waiting to be noticed. Scattered through every deep field, once you know to look, are hundreds of tiny, round, stubbornly red points of light. Astronomers needed a name for them, and every grand option felt like a guess. So they chose honesty over grandeur. They're called little red dots. That's the official term in the professional papers. Little red dots. And they are one of the strangest discoveries of this century so far, because they're not just unexplained, they're unexplained twice over. They live only in the early universe. They switch on in the first few 100 million years. They're everywhere for a while. And then, a billion or so years in, the population thins out and vanishes. Whatever they were, they stopped happening. Nothing in today's sky looks like them. And they're small, fantastically small for how bright they burn. Each one packs the light of billions of suns into a space 1/100th the width of a galaxy like ours. Whatever's inside them is crowded beyond anything the books describe. There are two serious guesses, and here's the beautiful trouble. Each one breaks something different. Guess one, they're stars. Just stars, but packed unbelievably close. Millions of suns crammed into the kind of space where our neighborhood keeps one or two. If that's true, then from a world inside a little red dot, there would be no night. The whole sky would be a ceiling of stars, wall to wall, horizon to horizon, a permanent silver evening, no darkness anywhere, ever. It's a lovely thing to picture from a dark bedroom. It also breaks the rules, because star cities packed that tight shouldn't be able to form or hold together by any process we've ever written down. Guess two, they're black holes. Each dot a young, giant black hole, wrapped in a thick cocoon of gas, glowing as it feeds. That explains the light's shape rather well. It also means the early universe minted enormous black holes in numbers our story never predicted. A whole hidden population, everywhere at once. And it comes with an awkward silence, because feeding black holes usually crackle with a sharp kind of light that the little red dots simply don't show. They're quiet in exactly the way they shouldn't be. So the two best answers are impossible stars or impossible black holes. Pick either, and a chapter of the books needs rewriting. The dots just sit there in the frames, hundreds of small red faces on the album's first pages, and nobody in the family can say who they are. You'd like the mood of the conferences, by the way. When the dots come up, the rooms fill, and the sessions run long, and they end without a verdict, which almost never happens in a field this careful. Clues keep arriving, and every clue cuts both ways. A few of the dots have been caught flickering slightly, brightening and dimming over months, which is exactly how a feeding black hole behaves, and exactly how a city of steady stars doesn't. Point for the black holes. But then the sharp X-ray light that feeding black holes always pour out simply isn't there. Hunted for and missing. Again and again. Point against. Some dots show the fingerprints of both at once. Starlight and furnace light braided together in one barcode, as if the answer might be both. A crowded newborn city of stars with a young giant feeding quietly in the middle of it, each hiding the other. And over all of it hangs the strangest clue, the vanishing. Whatever the dots are, the universe stopped making them. They crowd the first billion years, and then the population thins and fades, and is simply gone from every later page. Like a fashion, or a season, or a stage every young thing passes through exactly once. What switches off an entire species of light? Nobody knows that either. There's something gently comforting about it, if you hold it right. The universe had a phase, long before the sun, that it never repeated. And we only found out because we finally built an eye good enough to notice what's missing from the family album's later pages. There's a small tradition hiding in that humble name, and it's worth a smile in the dark. Astronomy has always named things by how they look before knowing what they are, and the names stick, wrong, and beloved. Planetary nebulae have nothing to do with planets. They're the exhaled shells of dying stars. But through early telescopes, they looked round and greenish like planets. And the name never left. Dark matter is simply the confession we made a moment ago. Dressed as a noun, even the Big Bang, the grandest name in science, began as a jab. The astronomer who coined it disliked the whole idea of a beginning. The phrase he tossed off on the radio stuck, and the idea's supporters liked the sound of it and kept it, the way a nickname from a rival becomes a badge. So when you hear little red dots, you're hearing the field at its most honest, mid-discovery, before the varnish goes on. Somewhere down the line, when somebody finally works out what the dots are, they'll get a proper name, dignified and Greek, and printed in the textbooks your grandchildren will doze through. And a few old astronomers will still call them the little red dots. Fondly, the way you keep calling a grown friend by the name they had in school. You're hearing science in its unfinished tense tonight. It's not a worse sound than the finished kind. To some ears, it's the best sound there is. And the black hole guess drags us straight into tonight's next impossible thing, because even the black holes we can identify out there are wrong. Let's take a breath and say plainly what a black hole is. Since it's the calmest monster in physics, gather too much matter into too small a space, and gravity wins completely. It makes a place where the pull is so strong that nothing, not even light, can climb back out. Not a vacuum cleaner. Nothing hunts you. Just a deep, deep well in the dark, with a door that only opens inward. We spent a whole night with them once, and the useful memory from that night is this. Black holes are patient. They grow by eating, and eating, for a black hole, is slow work. Here's why. As gas spirals down the well, it rubs against itself and glows, furiously. And that glow pushes outward, against everything still trying to fall in. The brighter the meal, the harder the push. Feed a black hole too fast, and its own dinner light shoves the rest of the food away from the table. So there's a natural speed limit on growth, a polite pace it can't sustainably beat. The limit has a name, the Eddington limit, after the astronomer who worked it out a century ago, and with that limit in hand, you can do bedtime arithmetic. Start with the seed a dying giant star leaves behind, a black hole of some tens of suns. Let it eat politely, without ever missing a meal, which never happens. Growing it into a giant of 1 billion suns takes longer than the early universe had existed. There simply wasn't time. That's the rule. And the rule was already creaking before Webb flew, because giant black holes have been embarrassing astronomers for 60 years. Back in the 60s, telescopes kept finding points of light that looked like ordinary faint stars but carried barcodes that made no sense, until one astronomer realized the barcode wasn't nonsense, it was stretched enormously, which meant the little point stood at a staggering distance, which meant it was outshining entire galaxies from a speck of space. What could pour out the light of 100 billion suns from a region not much bigger than our solar system? Only one engine in physics can. A giant black hole, feeding, its meal glowing white hot on the way down the well. They were named quasars, and they were the first proof that the deep past owned monsters, because their light is old light, and some of them were already blazing when the universe was a fraction of its age. That was the old version of the problem, and it was uncomfortable enough. Webb's contribution was to make it very much worse. It pushed the sightings deeper into the universe's first several 100 million years and found the monsters already installed, already enormous, already dining. The lighthouse problem moved into the nursery. Here's what that looks like in the frames. Webb and friends. Working with an X-ray telescope, it found a young galaxy, shining from when the universe was under 500 million years old, with a black hole in its middle roughly as heavy as all of the galaxy's stars put together. Sit with how strange that is. In today's universe, a central black hole is a rounding error, about 1,000th of its galaxy's weight, a raisin in the loaf. This one was half the loaf. It's a newborn that weighs as much as its whole family. And it isn't alone. The deep frames keep coughing up beacons, galaxies with cores outshining everything around them, powered by black holes of hundreds of millions, sometimes a billion suns, blazing away in the universe's first several 100 million years, ages before the books say their kind should exist. One of them, a faint thing from the young universe, was caught mid-meal, eating at about 40 times the polite limit, gorging as if the speed limit simply wasn't there, its dinner light somehow failing to push the food away. The referees checked that one hard, because it looked like a typo. It held. Do you want to feel the wattage of these things properly, just once, before we move on? Take the brightest quasar in the catalogues and try a thought experiment with it. Park it 30 light-years from Earth. That's a real neighborhood distance, farther than most of the stars you can name, 7 times farther than our nearest stellar neighbor, from 30 light-years away. An ordinary star is a pinprick you'd need a chart to find. That quasar would hang in our sky, as bright as the Sunday, a second sun, casting shadows, drowning the stars, turning midnight into noon, from 30 light-years away, powered by one black hole's dinner glowing on the way down. That's the kind of lamp the young universe was hanging out before it was properly out of its infancy. And maybe the strangest part is where all that light comes from. Not from the black hole itself, which gives nothing back. Ever. The blaze is the food. It's the swirling gas, rubbing itself white-hot in the last long spiral above the point of no return, shining hardest in the final moments, before it can never shine again. The brightest steady lights in the entire universe are, in the end, every quasar you'll ever hear of is the glow of matter announcing itself one last time on the way through the one door that never opens twice. The universe's greatest lamps are all doorways, and all the shine is goodbye. So, where do giant black holes come from? Too big, too early, too calm about it. There are 2 escape routes, and you'll notice a familiar shape to them. Route 1. The seeds were heavy. Maybe, in the dense young universe, some clouds of gas never bothered becoming stars at all. Maybe a whole cloud, 100,000 suns of it, slumped directly into a black hole in one long exhale, skipping starhood entirely, a seed born already huge. It's allowed on paper. Nobody has ever watched it happen. Route 2. The eating was rude. Maybe young black holes feast in wild bursts, far past the polite limit, faster than their own light can object. And the one caught at 40 times, the limit is the smoking kitchen. Also allowed. Also never really understood. And here's the twist worth taking to bed. Those cocooned little red dots from a moment ago, the quiet, crowded ones nobody can name, are exactly what a nursery of heavy seeds might look like from 13 billion years away. It's possible the 2 mysteries are one mystery, that the dots are the giant's baby pictures, and that one impossible thing has been quietly explaining the other all along, in plain sight, on the same album pages. Astronomers dream of endings like that. It's not proven, but it's the kind of ending this story has had before. Size, though, isn't even the strangest part of the early universe Webb has been mailing home. The strangest part is the manners. Everything out there is too calm. Think about what the first chapters ought to look like. The young universe was crowded. Everything closer together. Collisions constant. Gas pouring in cold and fast. Page 1 should be a building site. Wreckage, dust, shapeless tangles, galaxies, mid-crash, nothing finished, everything loud. That's what the simulations painted, and for good reason. And instead, over and over, Webb finds composure. It finds grand spiral galaxies, with long, elegant arms combed neatly around a bright core, our own galaxy's shape, showing up billions of years before that shape was supposed to be achievable. It finds disks spinning in smooth, settled circles, cold and orderly, the milk already stirred, at ages when the books say everything should still be splashing. One of them, found recently and nicknamed the Big Wheel, is a spinning disk about as wide as our entire Milky Way, photographed barely 2 billion years after the beginning, sailing calm and enormous through a crowded neighborhood that should have torn it to rags. Our own galaxy needed most of the age of the universe to become what it is. The Big Wheel did it in a seventh of the time, and didn't even look hurried. How do you even tell that a galaxy so far away is calm? It's a lovely trick, and it works like a choir. Astronomers can measure the motion of a galaxy's gas by listening to its light's pitch. Gas swinging toward you sings a slightly higher note. Gas swinging away sings slightly lower, and if you map the notes across the whole disk, you hear its manner of moving. A young, messy galaxy sings like a crowd, every part shouting in its own direction, splashy and hot and loud. A settled galaxy sings like a choir, everything circling together, in tune, the internal jostling died away to a murmur. Webb, working alongside a field of radio dishes high in the Chilean desert, has now listened to galaxies from the universe's first billion years, and heard, in case after case, the choir. Cold, thin, orderly disks. Rotating with the composure our own galaxy took most of forever to find. It shouldn't be possible to comb a galaxy that fast. Every collision, and the early universe was nothing but collisions, reaches in and scrambles the singing. Settling is supposed to be what the long, boring ages are for. Yet there they are, calm at dawn, note perfect, spinning like the whole business of being a galaxy had been rehearsed somewhere beforehand. One astronomer described the feeling as arriving at what you were told was a construction site and finding a finished cathedral, quiet, swept, and lit. And then there are the retired ones, which might be the quietest shock of all. Scattered through the early frames are galaxies that are already dead. That's the real word astronomers use. A dead galaxy isn't dark, it still shines, but it has stopped making new stars entirely, and its old stars are slowly reddening together, like embers settling after a fire, a long, warm afterglow with nothing new being lit. Around us today, dead galaxies are common and elderly, and that's fine. Everything tires eventually. But Webb has photographed galaxies that were already retired when the universe was under 2 billion years old. Read their stars closely, and it gets stranger. The stars' own birth dates reach back almost to the very first dawn, so the whole life happened in a sprint. Born among the earliest things there were, a furious youth of star-making. And then, while the universe around them was still practically an infant, they stopped, folded their hands, and settled into a long quiet that has lasted ever since. Retirement portraits, pasted on the nursery page of the album. Nobody securely knows what stops a young galaxy that fast. The leading suspect is the previous mystery. A giant black hole, grown too big too soon, can blow the galaxy's cold gas kitchen empty. And no kitchen means no new stars. If that's the story, then the impossible giants and the impossible retirees are cause and effect. 2 more pages of the album quietly explaining each other. The early universe keeps doing this. It doesn't just break the books, it breaks them in a pattern, as if all the broken pieces were once part of one sentence we haven't learned to read yet. Even the ingredients showed up early. This next impossible thing is about ash, and it starts closer to home than any of the others, because some of the ash is you. The calcium in your bones, the iron in your blood, the carbon in your skin, none of it existed when the universe began. The beginning made only the 2 simplest, lightest gases there are, hydrogen and a little helium. A universe of pure fuel with nothing else on the shelf. Everything heavier was cooked later. Inside stars, fused in their hot hearts over their lifetimes, and then scattered when they died, blown out into the dark as glowing ash. New stars formed from that enriched gas, cooked it further, died in turn. Generation after generation, the universe slowly salted itself. Your body is the current draft of that recipe, several stellar generations deep. Run a thumb along your knuckles if you're still awake enough. The calcium holding their shape was assembled in the hearts of stars that died before the sun was born, more than one of them, in more than one corner of the galaxy, and their ash drifted for ages and gathered and became a cloud. And the cloud became the sun and its worlds, and some of it became the person listening to this sentence. Have you ever noticed you can't point to where you're from? Nobody can, not really. The atoms in your left hand and the atoms in your right may come from different stars entirely. You're not from a place. You're from a series of fires, mixed thoroughly, and every person you've ever loved is from the same fires, which perhaps explains a few things. It's one of the warmest facts in science, and you can hold it while checking the arithmetic that comes with it. Cooking takes time. A star has to be born, live, and die before its ash joins the clouds. And even the fastest lives take millions of years, with the full seasoning of a galaxy taking far longer. So the first pages of the album should be plain, unsalted, pure hydrogen starlight, nothing else. And Webb reads the barcodes of galaxies from the first few 100 million years, and there it is, again and again. Carbon, oxygen, the notches of ash, sharp and unmistakable, in light that left before ash was supposed to exist in any quantity worth finding. Worse than the barcodes, there's soot. Some of those infant galaxies are visibly dusty. Cosmic dust, the fine dark soot that dims and reddens starlight, isn't primitive stuff at all. It's fancy. Grains of carbon and silicates, the specific smoke of many stellar lifetimes, the thing our own galaxy took ages to accumulate. Finding a thickly dusty galaxy at the dawn is like walking into a supposedly brand new house and finding the chimney already black. Somebody's been burning fires here for years, and the calendar says the house was built last week. The ash arrived before the fire had had time to burn. So what's the way out? The favorite suspect is wonderful, and it ties 3 of tonight's knots with one rope. Maybe the first stars weren't like today's stars. The first generation, formed from that pure unsalted gas, may have run enormous giants of hundreds of suns, and giant stars live fast. A small star is a candle that burns all night. A giant is a bonfire, gone by midnight. Stars like that would flood their nurseries with ash in a blink, cook the chemistry early, blaze bright enough to help explain those 2 brilliant infant galaxies, and collapse into hefty black hole seeds when they died. A first generation of monsters would loosen 3 impossible knots at once. It's a lovely theory, with one inconvenience. Nobody has ever seen a first-generation star. Not one, ever, anywhere. They're near the top of Webb's wanted list. And it's entirely possible a few are already sitting in the deep frames, faint and unrecognized, waiting for someone to read the right barcode. To feel why giants would change everything, walk one giant's life with me. Briefly, because it's a bedtime story in itself. A star's life is a long argument between 2 forces. Gravity squeezes inward, always, and the burning heart pushes outward, and the mass of the star decides how the argument goes. A small star is a miser. It sips its fuel so slowly it can glow for hundreds of billions of years, longer than the universe has existed so far, a candle that outlasts every house it was lit in. Our sun is middle class, a steady lamp with billions of years still in the tank. But a giant of 100 suns is a bonfire in a gale. It burns blue-white, furiously, squandering in 1,000,000 years what the sun spends in 10 billion, cooking heavier and heavier elements in its heart, carbon, then oxygen, all the way to iron, the ash that won't burn, and when the heart fills with iron, the outward push fails. Gravity wins the old argument in a single second, and the star collapses and detonates, flinging its whole pantry of new-made elements out into the dark, a bell of glowing ash swelling through the nursery that raised it. The cloud it seeds makes richer stars, and the collapsed heart it leaves behind is, quite often, a black hole. Now imagine the first generation, with the whole universe's gas to feed on and nothing to slow it down, running almost entirely to giants. Ash everywhere, in a blink. Brilliance everywhere, in a blink. Heavy seeds everywhere, in a blink. That's why the theorists keep circling back to monsters. One early bonfire generation, and half of tonight's impossible album starts to look like a family resemblance. Now, all that early starlight ran up a bill, and the bill is our next problem. Because it doesn't balance. This one's about fog. Step back to the very early universe, before any stars at all. After the beginning, once things cooled enough for atoms to form, the whole universe filled with neutral hydrogen gas, everywhere, a cosmic fog, and then the lights went out. Astronomers genuinely call what followed the Dark Ages. Millions of years of a universe with no stars, nothing shining anywhere, just warm fog slowly cooling in the dark, the deepest quiet there has ever been. Then, gravity being gravity, the fog began to gather and knot, and one by one the first lights switched on, and starlight, the fierce end of it, does something specific to hydrogen fog. It cuts it. It strips the atoms and turns the fog clear, the way morning sun burns the mist off a valley. Slowly, patch by patch, each young galaxy clearing a growing bubble of transparency around itself, until the bubbles met and the whole universe went clear. It's called reionization, and it's the reason you can see the stars at all tonight. The fog has stayed burned off for 13 billion years. Your window looks through what the first galaxies cleared. Stay in the Dark Ages a moment longer, though, because, as sleep material goes, nothing in science comes close. How long was the longest night? Millions of years at the least, with nothing anywhere that shone. No stars, no galaxies, no lamps of any kind. Just endless warm fog, thinning and cooling as the universe grew, in perfect darkness, in perfect quiet, everywhere at once. If you could have floated there, you'd have seen exactly nothing, in every direction, for longer than humans have existed. And yet the whole time, the darkness was working. Gravity doesn't need light. All through the long night, the invisible scaffolding was gathering. Fog drifting towards fog, the heavy threads and knots of the future universe assembling themselves in the black, every galaxy that would ever shine already forming up as an unlit shape. The universe built its entire framework in the dark, the way a garden does its deepest work in winter. And then, here and there, in the densest knots, the fog finally pressed itself tight enough to ignite, and the first lights in the history of everything switched on. Nobody has ever seen that moment. It's perhaps the single sight Webb was most built to hunt. The first morning, the cosmic dawn itself. Every deep field is, in the end, an attempt to photograph the end of that night. When you switch your own lamp off shortly, give it one thought. Darkness, in this universe, has never once been empty. It's where everything gets ready. And how did the morning actually spread when it finally came? Not everywhere at once, and that's the detail worth picturing. Have you ever watched mist burn off a valley from a window? The sun doesn't lift it in one motion. It opens holes. A clear patch over the river first, then one over the far field. Each pocket of clarity growing at its own pace, until, somewhere in the middle of the morning, the patches touch and join, and suddenly it isn't fog with holes in it anymore. It's a clear day with a few last rags of mist. The universe's dawn worked exactly like that, stretched over hundreds of millions of years. Around every young galaxy, a bubble of clearness slowly swelled. The fog cut back by starlight. Each bubble, an island of transparency in an ocean of murk. From inside one, you'd have seen your own galaxy's neighborhood honestly, and then, at the bubble's edge, a soft wall where the wider universe blurred away. For ages, the cosmos was an archipelago of these clear islands, growing toward one another through the dark. Each one the work of one gathering of stars, none of them aware of the others, and then they met. Bubble touched bubble, clarity linked with clarity, and over the last stretch of that long morning the islands merged into one open, transparent universe, the one your window looks through tonight. When Webb reads the late fog, it's reading the last rags of the mist. The deep fields are, among everything else, a photograph of the morning the lights of the universe first saw each other. For decades, the worry ran one way. The early galaxies we knew about seemed too few and too dim to burn off all that fog on schedule. The light budget came up short, and everyone assumed the missing lanterns were simply too faint to see. So Webb went and counted them with a glorious trick. It used gravity itself as a magnifying glass. A massive cluster of galaxies bends the space around it, and light from far behind gets curved and focused, brightened sometimes 100-fold. Nature's own reading glasses held up to the first pages. Peering through them, Webb found the faint little galaxies of the dawn, swarms of them, and measured their light. And the budget problem flipped upside down. The little ones aren't too dim. They're too bright, several times brighter in exactly the fog-cutting colors than the books had allowed. Which sounds like the puzzle got solved, until you run the new numbers forward, with lanterns that strong everywhere. The fog should have burned off far too early, long before it actually did. And we know when it actually cleared, because the light of distant beacons still shows the late fog hanging around, damp and stubborn, well past the new predicted clearing time. So the ledger refuses to balance in either direction now. Count the light, and there's too much of it. Watch the fog, and it lingers anyway. Somewhere in our story of the universe's first morning, something about light or fog is being counted wrong, and nobody has found the error. The morning came on time by the old sums, too late by the new ones, and the account books of the dawn simply do not close. Where's the error hiding? The honest answer is that every line of the ledger has a little give in it, and the softest line is almost charming in how homely it is. It's about leaky houses. A young galaxy makes its fierce fog cutting light deep inside itself, where its own local gas is thickest, and most of that light never gets out. It's absorbed at home, in the galaxy's own halls, before it can touch the wider fog at all. So the sum that matters isn't how much sharp light the little galaxies make, which Webb can measure, but how much escapes the house, which almost nothing can measure at those distances. Astronomers call it the escape fraction, and it might be the most consequential number in the early universe that nobody can actually read. If the first galaxies leaked generously, the fog burns off too early, and the books break one way. If they hoarded their light, the burning slows, and the books break the other way. The truth is being squeezed from clever side routes, nearby galaxies used as stand-ins, statistical fingerprints in the fog itself, and the answer moves a little every year. It's a strange thought to take to bed, that the timeline of the universe's first morning currently hinges on the draftiness of houses no one can visit. But that's often what a scientific crisis actually is, up close. Not a broken universe. One stubborn, homely number, wearing a fog around itself, waiting for a better lamp. If all of this feels far away, out at the edge of everything, the next impossible thing lives in this room too. It's about a single number, and the number is the universe's speedometer. You'll remember from other nights that the universe is growing. Distant galaxies drift apart. not because they're flying through space, but because the space between them is stretching. Like raisins in a rising loaf, every raisin watching every other raisin recede. Don't worry about your bedroom, by the way. Rooms, planets, galaxies, and everything held together by gravity or love stays its own size. Only the deep, empty stretches grow. But how fast do they grow? That number sets everything. Run it backward, and it tells you the age of the universe, the date of the first dawn, the whole timeline of the album. Astronomers have two completely independent ways to measure it, and this is where the trouble starts. Because the two ways give two different answers, and they have for years, and it's getting worse instead of better. Way one climbs a ladder, rung by rung, from this room outward. The first rungs are stars whose true brightness we can know. A century ago, a quiet astronomer named Henrietta Leavitt, hired to examine photographs of the sky for pennies an hour, noticed that a certain kind of pulsing star keeps a perfect secret schedule. The slower it blinks, the brighter it truly is. That little discovery is one of the most important in the history of astronomy, because a star whose true brightness you know is a lamp of known wattage. See how bright it looks, and you can tell how far it stands, the way you judge the distance of headlights on a dark road. Her blinking stars reach the nearby galaxies. There they calibrate the next rung, a kind of exploding star that always detonates with nearly the same true brightness, visible across half the universe. Rung by rung, lamp by lamp, you climb out into the deep and clock the stretch. The ladder gives its answer. Way 2 skips the ladder entirely. It goes straight to the oldest light there is, the afterglow of the beginning itself, the baby picture of the whole universe, and reads the recipe printed in its speckles. How much matter, how much gravity, how much push. Feed that recipe into the equations, run the universe forward from infancy, and out comes the same speedometer number. Predicted rather than measured. 2 roads, 1 number. They disagree. It's worth a moment on that baby picture. Because you might be wondering how a photograph of infancy can tell you anything about speed. The afterglow is real, and it's everywhere. Point a sensitive enough receiver at any patch of sky, between the stars, between the galaxies, and you'll pick up a faint, uniform whisper of warmth, coming from every direction at once, the cooled leftover light of the universe's hot beginning, stretched over all this time, from blinding glare into a murmur just above the coldest cold. It's the oldest light that exists or ever will, and it's passing through your bedroom right now, a few of its ancient photons ending their journey in your walls while you listen. Printed across that whisper are speckles, tiny warm and cool patches, and those patches are sound, really. They're the frozen ripples of pressure waves that rang through the young universe like tones through a bell, and their sizes are set by the recipe. How much ordinary stuff, how much dark scaffolding, how much push in the dough. Astronomers have measured those speckles to exquisite precision, and the recipe they spell out predicts nearly everything we see, with stunning success, across 13 billion years. Nearly. Run that same recipe forward to compute how fast today's universe should be stretching, and you get the number that disagrees with the ladder. The baby picture and the grown portrait won't reconcile. It's the finest baby book ever kept, describing a child that grew up, by one small, stubborn measure, into somebody slightly else. The gap is nearly a tenth. And before you shrug at a tenth, hear the strange part. Both camps have spent years hunting their own mistakes, and both keep certifying their sums to within a few parts in 100. The disagreement is several times larger than either side's stated doubt. It's 2 careful accountants, each swearing to the penny, whose books differ by real money. For a while, everyone's favorite suspect was the ladder's first rung. Those blinking stars sit in crowded fields, and the older telescope's photographs blurred them into their neighbors, maybe skewing the lamps. It was exactly the kind of small, boring error that usually dissolves these dramas. and Webb was exactly the machine to check it, with vision several times sharper. So Webb rephotographed the blinking stars, cleanly separated from their neighbors, and remeasured the ladder's bottom rung. The rung held. The lamps were honest. The disagreement survived its best chance to die quietly, and with it, the polite explanations are running out, which leaves the impolite ones. Perhaps some subtle error still hides where nobody has thought to look, or perhaps the recipe read from the baby picture is missing an ingredient, some extra push in the universe's first act that faded and left no trace except this stubborn arithmetic. That would mean new physics, the real kind. Tonight, nobody on Earth knows which it is. The two numbers stand in their corners, and the age of everything, the actual date of the first morning, sways gently between them. Since her lamps are holding up the whole argument, Henrietta Leavitt deserves her story told properly. She worked at the Harvard Observatory a century ago, one of a room of women hired as computers, which back then meant a person who computes. The astronomers, all men, ran the telescopes. The women measured the photographs, star by star, glass plate by glass plate, for a wage of pennies an hour, and were expected to have no ideas of their own. Leavitt, who had lost most of her hearing in her 20s, was assigned the tedium of variable stars, the ones that brighten and dim. On plates of the two little companion galaxies you can see from the southern hemisphere, she logged thousands of them, night after night, year after year, and in that ocean of tedium she caught what nobody else had. Her blinking stars kept a schedule, slow blinkers bright, fast blinkers faint, so exact you could set rulers by it. She published quietly. The men kept the telescopes, but every rung of the ladder that measures the universe now stands on her law. When the size of the cosmos was discovered, it was discovered with her stars. When the expansion was discovered, her stars again. A few years after she died, still barely known. A member of the Swedish Academy went looking to nominate her for the prize she plainly deserved, and found he was too late. The universe's measuring tape is, and will always be, a hand-me-down from a half-deaf woman doing piecework astronomy for pennies. Webb, all gold and grandeur, spent part of its precious first years simply checking her stars, and her stars were fine. It's worth being clear about what's actually at stake in this argument, because it isn't small. That one number is the universe's clock speed. Run it backward, and it dates the beginning. If the ladder camp is right, the universe is nearly 1 billion years younger than the age printed in the current textbooks. And every date in tonight's album shifts. Every dawn, every first star, the whole calendar compressing like an accordion. The grown galaxies on the first pages would have even less time to grow than we thought, which makes every impossible thing tonight slightly more impossible. And if the baby picture camp is right, then the ladder, checked and rechecked by our finest instruments, is somehow lying in a way no one can catch, which would be its own kind of frightening for a science built on ladders. The popular escape is a third door. Perhaps both camps are right. And the universe itself changed its pace. An extra ingredient in the young cosmos, a burst of push that faded early, and left nothing behind except this quiet disagreement between its childhood and its old age. Physicists have drafted candidates with names like early dark energy, and none of them have a shred of direct evidence yet. What they have is a gap that won't close, guarded now by Webb on both sides. Somewhere in that gap, most astronomers quietly suspect, is the next chapter of physics, folded up very small. Now let's come nearly home, because the impossible isn't only a dawn thing. Some of it is floating in a nursery just down the road, and you can find the nursery from your garden. On a clear winter evening, look for the 3 bright stars in a short, tidy row. The belt of Orion, the easiest signpost in the whole sky. Just below the belt hangs a smaller, fainter line the sword, and in the middle of the sword, if the night is dark enough, you'll see a soft little smudge, like a thumbprint of light. That smudge is not a star. It's a cloud, a vast nursery of gas and dust, where thousands of stars are being born right now. The nearest big star factory we have. Every culture that ever watched the sky noticed it. Webb turned its golden eye there early on, partly for the beauty, and the beauty arrived. Newborn suns lighting their cocoons like lamps behind curtains. But sifting the frames, astronomers found something that wasn't on any shopping list. Worlds with no suns. Hundreds of them, the heft of Jupiter, drifting free through the nursery, belonging to nothing, orbiting nothing, just falling through the dark on their own. Young worlds still hold their birth warmth. They glow faintly with it, like fresh bread cooling in a dark kitchen, and that faint warmth is exactly what a cold, golden eye sees best. The nursery is full of orphans. Nobody had ever seen them before, because nobody had ever owned an eye that could. Free-floating worlds weren't the shock, though. Astronomers suspected those existed, worlds flung from their families during the rough early years. When young planets jostle and the biggest sibling usually wins. The shock was that the orphans came in pairs. About 40 of the couples turned up in that one nursery. 2 Jupiter-sized worlds circling each other as they drift, bound together, belonging to nobody but each other. The name the astronomers coined shows you how unprepared everyone was. Jupiter mass binary objects, jumbos. Nobody predicted them, and to this day nobody has a clean story for them, because they're impossible twice over. Worlds that size shouldn't form alone in open space, the way stars do. The clouds are too small to collapse. And if they formed around stars and were thrown out, the throwing should have separated them. A gravitational slingshot is violent, and expecting 2 planets to hold their pairing through it is like expecting 2 dancers to keep hands clasped while being hurled from a spinning carousel. Once might be luck. 40 times is a rule we haven't met. Theories are circulating, none comfortable, all strained. And while the theorists argue, the couples themselves just carry on, out there tonight. In the dark, between the newborn stars. 2 worlds, warm from birth, no sun, no address, falling together through a nursery, holding on to each other. Of everything in tonight's album, they might be the impossible thing that's easiest to love. What would bedtime even look like on a world like that? There's no sunrise there, ever, and no sunset either, because there's no sun to do the rising. No days, no seasons, no years that mean anything. The only calendar is the partner, the other world, swinging slowly through the sky on its long mutual orbit, a dim, warm disk among the stars, the one landmark in a life of drifting. Around them both, the nursery glows, great curtains of gas lit softly from within by other people's newborn suns. The way city light glows on clouds you can watch from your bed. It would be a sky of permanent, gentle evening. And here's the wider truth those 2 belong to. The galaxy, it turns out, is generously stocked with sunless worlds. Counting studies suggest the homeless ones, flung from their families or born adrift, may outnumber the stars themselves, which would mean the most common kind of world in our galaxy is one with no sun in its sky at all. Trillions of them, sailing the dark between the lit systems, unseen and unsuspected until eyes like Webb's came along. The universe we grew up picturing was a universe of porch lights, every world tucked close to its own warm star. The real one is mostly travelers. Mostly dark roads between the lit houses, and on the dark roads more worlds than there are porches, falling quietly along their own ways. Some of them, at least in Orion, falling in pairs. Let's rest for a while now, because not everything the golden eye sees breaks the books. Some of it just makes the universe larger and softer at the same time. And a few of those pictures belong in tonight's album too. Take the most famous photograph in astronomy, the one you've seen on posters and classroom walls. 3 great towers of dust and cold gas rising into a glowing sky. The pillars of creation. The tallest of the towers is about as long as the whole distance between our sun and its nearest neighboring star. The older telescope made that portrait a generation ago, and it became the way our species pictures the deep. When Webb re-raised its eyes to the pillars, something lovely happened. Dust that stood opaque for the old telescope is translucent to a warmth-reading eye. Webb sees into the towers, and inside, scattered through the columns like lanterns behind a curtain, are newborn stars, small and reddish and just switching on. The pillars turn out to be full. They were never monuments. They're nurseries, lit from within, photographed mid-birth. Nearby, in the closest of all the star nurseries, in the constellation of the Serpent-Bearer, Webb took a birthday picture. 1 year after its first images, of a small cave of gas where a few dozen young suns are waking up. Some of them wear flat discs of leftover dust, seen edge-on, thin as record albums. Every one of those discs is a solar system's first morning, the table set before breakfast. Planets not yet begun. You're looking at the kind of picture our own sun would have been in 4.5 billion years ago if anyone had owned a telescope. And some of those discs already show gaps, thin dark grooves swept clean by things too small to see. Which is what a planet looks like the year before anyone can prove it's there. Closer still, the Golden Eye has been visiting the neighbors. It photographed Neptune, the farthest of the planets, and recovered something almost nobody alive had seen clearly: its rings. Faint, ghostly hoops, barely there, last viewed properly when a passing probe swept by more than a generation ago. In Webb's frame, the blue giant glows like frosted glass, ringed in silver thread, with a handful of its small moons standing round like distant porch lights. And beyond the neighborhood, Webb has learned to do something no machine before it could do reliably, which is to read the air of worlds around other stars. The trick is beautiful. When a far world crosses in front of its own sun, a thin ring of its atmosphere gets backlit, and the starlight that reaches us has filtered through that alien sky, carrying its barcode. Webb read one such sky, a giant world several hundred light-years away, and found the sharp, unmistakable notches of carbon dioxide, the first time that gas had ever been clearly identified in the air of a world outside our solar system. It found stranger chemistry too, a molecule in those clouds that only forms when starlight itself edits the air. Weather being invented on a world we will never visit, recorded in a rainbow. And around a smaller, cooler world, one that might be wrapped in a deep, warm ocean beneath a hydrogen sky, Webb caught hints of methane and carbon dioxide, and one faint whisper of a molecule that, on Earth, is made almost entirely by life in the sea. Hold that one gently. The whisper is disputed, the measurement is being redone, and the sober money says ordinary chemistry will explain it. But notice where you're falling asleep. You live in the first generation of your species that can lie in bed and argue, with data, about the weather on worlds around other suns. The argument itself is the miracle, however it resolves. That door doesn't close again. And one more from the neighborhood, because it belongs in any album of gentle wonders. Around Saturn circles a small ice moon called Enceladus, white as fresh snow, barely the width of a modest country. Years ago, a passing probe discovered that it leaks. Through cracks in its southern ice, the moon vents its hidden ocean into space. A spray of salt water and ice crystals from a sea no one has ever seen, warmed by the moon's own kneaded interior. Webb looked at that little snowball from its post 1,000,000 miles from Earth, and even at that absurd distance it saw the breath. A plume of water vapor, rising off the moon and stretching many times the moon's own size, a fountain taller than the world it comes from, feeding a faint ring of fog that wraps all the way around Saturn, a moon watering its planet's garden. Somewhere under that ice, right now, there's an ocean that has been dark and liquid and salted for billions of years. And every hour it sends a little of itself up through the cracks and out into the ring light. None of this breaks a single book. It's here because the same golden eye that catches impossible galaxies also catches a small moon, quietly exhaling. And because it's good to remember, between mysteries, that the universe was never only strange at the edges. It's strange in the suburbs too. And the strangeness there smells of snow and sea salt. The beauty, you should know, is now an annual tradition, kept like a family holiday. Every year, on the anniversary of the telescope's first pictures, the team chooses one image and releases it purely for loveliness. No crisis attached, a birthday portrait from the deep. One year it was that nearby nursery with its newborn sons in their dusty cave. Another year it was a pair of colliding galaxies that, by pure chance of angle, look exactly like a penguin standing guard over its egg, tens of millions of years into a slow embrace that will end with them becoming one. Another, a vast pour of glowing gas and starbirth that astronomers had long ago nicknamed for a cat, re-photographed in warmth-coloured light until every toe of it glittered with hidden newborns. There's something quietly wonderful about a machine built to test the story of everything spending its birthday on penguins and cats' paws. But it's not really a break from the mission. It's the other half of it, the same eye, the same cold, the same patience, pointed at splendour instead of puzzles, as a reminder of what all the arguing is about. The universe isn't a problem set. It's a place, ridiculous and gorgeous, where dying stars exhale rings, where galaxies do accidental impressions of penguins, where a moon waters its planet's garden, and the fact that the place also refuses to fit our books is simply the final proof that it's real and not something anybody made up. And once, while everyone was busy with the deep pages, something wandered into our own yard, and the golden eye swung around to meet it. A survey telescope in Chile, one of the tireless little machines that photograph the whole sky night after night, flagged a faint moving dot. Astronomers computed its path, then computed it again, because the path was wrong. Every comet and asteroid that belongs to the Sun travels a closed loop. It comes around, however slowly. This dot was on an open curve, the shape that means passing through, a road with no return lap. It was a visitor from another star, only the third one our species has ever caught in the act, and by the strange arithmetic of chance, the first two had already taught us to move fast. So the observatories of the world turned together, and Webb got its look while the visitor was still inbound. A small dirty snowball from another family's solar system, beginning to warm and breathe as it neared our Sunday Webb read the breath. It was strange. Where our own comets sigh out mostly water vapour, this one breathed carbon dioxide, far richer in it than any comet of ours on record, its water oddly scarce, as if it had been baked and frozen by a different history under a different star. Some astronomers, reading its speed and its road, argue it comes from an older neighbourhood of the galaxy, and may itself be older than our Sunday. A pebble from somebody else's album dropped through our kitchen door. It rounded the sun in the autumn, quickened, and is already on its way back out. One way, downstream, the visit finished. It took no photographs of us that we know of. It left only the lesson, which is worth keeping. The dark between the stars isn't sealed. It trades. Mail arrives, unannounced, from other suns, and sometimes the whole world's telescopes get to read a page of somebody else's story before the wind takes it back. Since it was the third, you might be wondering about the first two, and they make a tidy little family portrait of how strange this new business is. The first visitor ever caught arrived less than a decade ago, and it remains the oddest. It was seen only on its way out. Already leaving, a fast, tumbling sliver that the light curve said was shaped like nothing else in the sky, absurdly stretched, a cigar or a pancake of a thing, and it showed no comet's breath at all. Yet it drifted off course as if something gentle were pushing it. The arguments about what it was outlived the object itself, which is what happens when the guest leaves before anyone reaches the door. The second visitor, a couple of years later, was the opposite. An utterly ordinary comet that simply happened to belong to another star, and its ordinariness was its own comfort. Other suns, it said, make comets rather like ours. And then came the third, the carbon dioxide breather, caught early enough this time for the whole planet's instruments to study it properly, Webb included. 3 visitors, 3 characters, 1 lesson repeated. These things pass through constantly, and always have. For all of human history until this decade, they slipped by unseen, whole emissaries from other solar systems crossing our sky, while nobody owned an eye that could notice. A new survey telescope now opening in the mountains of Chile, named for an astronomer you'll meet properly in a few minutes, is expected to catch one every year or two from here on. The visits were never rare, only the noticing was. So now the album is heavy. Grown galaxies in the baby pictures, little red faces no one can name, giants in the nursery, retirees at the dawn, ash before fire, too much morning light, a speedometer at war with itself, couples of homeless worlds, and a cold visitor breathing the wrong breath. What is anyone supposed to do with a pile of impossible things? Here's the gentle answer, and it's the deepest one tonight has. We've been exactly here before. Impossible piles are not a malfunction of science. They're how it breathes in. 2 centuries ago, the finest scientific minds in Europe knew and taught that stones do not fall from the sky. Farmers kept reporting them anyway, stones arriving with thunder out of a clear afternoon, hot to the touch. The academies filed the reports under superstition, and a few museums quietly threw their meteorite collections in the rubbish, embarrassed to own such nonsense. Then one spring afternoon, over a small town in the French countryside, the sky delivered its rebuttal, thousands of stones at once, clattering onto roofs and gardens in front of an entire town's worth of witnesses. A young physicist was sent to investigate, interviewed everyone, walked the fields, weighed the evidence, and wrote it up plainly. The stones fall. The sky was right. The books were wrong. And within a few years, every academy in Europe had accepted a new fact of nature that had been landing on farms the whole time. And do you see what actually went wrong there? It wasn't stupidity. The academies were full of brilliant people doing exactly what brilliant people are trained to do, defending hard-won knowledge against a world full of easy nonsense. The reports of falling stones arrived tangled up with reports of weeping statues and rains of frogs, and the learned threw out the treasure with the tangle. Their real mistake was quieter, and it's one you can check yourself for from bed. They decided what the sky was allowed to do before looking at what it did. That's the exact trap the deep field gamble was built to avoid, and the exact trap the little red dots are testing us with right now. Notice that today's astronomers, whatever else you might say about them, have learned the old lesson beautifully. When the impossible galaxies appeared, nobody filed them under nonsense. The pictures went straight into the journals, wrongness and all, and the telescope went back for more. The whole system is now built to protect the strange report until it can be checked, because the strange report is, once in a lifetime, the stone that actually fell. There's something restful in that, if you let it land. The people minding the universe's story have stopped guarding the door against surprises. They've propped it open and hung a golden eye outside it, and they sit up on purpose, hoping to be wrong about something wonderful before they die. That's the temperament watching the sky on your behalf tonight. Sometimes the impossible thing is a missing object. The planet Uranus, for decades after its discovery, refused to follow its predicted path, drifting off course by a hair, then a hair more, as if something unseen were tugging its sleeve. Two mathematicians, one in France, one in England, each took the misbehavior and worked it backward, computing where a hidden planet would have to stand to cause exactly that limp. The Frenchman posted his answer to an observatory in Berlin, and on the very first night of looking, there it was, a new world, Neptune, sitting within a finger's width of the predicted spot, a planet discovered at the tip of a pen. The impossible wobble was a doorbell, and behind the door stood a world. But sometimes, and this is the part to hold on to, the missing thing doesn't exist, and the impossible is pointing somewhere deeper. The planet Mercury had a limp of its own, a slow drift in its orbit that the same trick should have solved. Astronomers computed the hidden planet responsible, named it in advance, Vulcan, and hunted it for half a century. Respectable observers even claimed sightings. It was never there. Mercury's limp had no missing object behind it. It had a missing rule. It took a former patent clerk named Einstein, rebuilding gravity itself to explain it. Space bends. The sun's mass curves the very floor Mercury rolls on, and the limp was the signature of that curvature, visible the whole time to anyone with the right idea. Same kind of clue, opposite kind of answer, and you can never tell in advance which kind you're holding. That's the fork in the road, where all of Webb's impossible things now stand. Take the grown galaxies on the first pages. Maybe they're a Neptune, a missing object, something ordinary we haven't counted, gas turning to stars far more eagerly in the dense young universe, first-generation monster stars burning brighter than anything alive today. Or maybe they're a Mercury, a missing rule, a flaw in the recipe itself, in our story of how the darkness clumps and the cosmos keeps time. There's even a candidate waiting in the wings, because astronomy already owns one enormous unsolved wobble. Half a century ago, a young astronomer named Vera Rubin measured how fast galaxies spin at their edges and found them all spinning too fast, so fast their outer stars should fly off into the night. They don't. Something unseen holds every galaxy together, 5 times more of it than everything we can see, and after 50 years of searching, nobody has ever caught a single particle of it. We call it dark matter, which is an honest way of writing down that we don't know. Whatever it is, it's the scaffolding the first galaxies grew on. If it clumped earlier or harder than our recipe says, grown-ups on the first page might be exactly its fingerprints. One impossible thing may yet turn out to be the answer key for another. And somewhere on Earth tonight, someone is checking precisely that. And since we're standing at the wilder end of the shelf, you should hear the boldest idea anyone has floated for the impossible early lights, because it's almost too strange to say in a calm voice. A few serious physicists have proposed that some of the very first bright things Webb sees might not be galaxies of ordinary stars at all, but a kind of star nobody has ever confirmed, enormous, swollen, cool giants powered not by burning anything, but by dark matter itself, annihilating gently in their hearts and lighting them from within. They're called dark stars, which is a contrary name for things that would actually shine with the light of billions of suns each. If they existed, single objects could masquerade as whole early galaxies, and several of tonight's puzzles would quietly deflate. Most astronomers doubt it, politely and firmly. The idea requires dark matter to behave in a very particular way nobody has demonstrated, and extraordinary claims wait for extraordinary barcodes. But nobody has managed to rule it out either. And a few of Webb's distant little points match the predicted colors uncomfortably well. Hold it lightly, the way you'd hold any wild card. It's on the table because this is what a genuinely open moment in science looks like from inside. The sober explanations and the strange ones sit in the same folder for a while, waiting for the same data. And once in a century or so, to everyone's delight and alarm, the strange one wins. And if the answer turns out to be the deep kind, the missing rule, it wouldn't even be the first time the whole universe pulled that on us. A century ago, every sober scientist alive, Einstein included, took for granted that the universe as a whole was eternal and still, a fixed hall of stars that had always stood and always would. Then, a Belgian professor of physics, who was also a priest, took the new equations of gravity at their word, and the equations said the hall couldn't stand still. It had to be growing, and if it was growing, it once had a first morning. Einstein told him, roughly, that his mathematics was correct and his physics was abominable, and then the telescopes came in on the priest's side. Galaxy after galaxy measured rushing apart, and Einstein, to his lasting credit, followed the light and changed his mind. The expanding universe, the beginning itself, the entire album we've been leafing through tonight, every bit of it was once the impossible conclusion nobody wanted. The books lose their argument with the sky every single time. That's the secret the word impossible has been keeping all night. It never marks the place where the story ends. It marks the place where the next chapter is already being written, and the fact that Webb keeps finding impossible things doesn't mean the telescope is broken or that the universe is. It means the eye finally got sharp enough to catch reality doing something we haven't understood yet. Astronomers will tell you, quietly, over coffee, that this is the best time to be alive in their science for 100 years. Confusion, in astronomy, is the sound of a door opening. It's also worth knowing how the door will actually open, because it won't be the way films tell it. There will be no single night when someone leaps up from a screen shouting that they've solved the early universe. The answer will arrive the way dawn does, gradually, from several directions at once. A little of it is arriving already. Some of the impossible galaxies have been politely dissolving as measurements sharpen, weights trimmed, distances corrected, the puzzle shrinking to its hard, true core. That's the machinery working, not the mystery dying. The core that refuses to dissolve is where the treasure is. Over the coming years, Webb will stack deeper stairs. The barcodes will pile up by the thousand. New observatories will come online to check its homework from other angles, and one by one, tonight's impossible things will be sorted into their two ancient bins. Some will turn out to be Neptunes, missing objects, ordinary physics we hadn't counted, monster first stars, hungry early gas, some unimagined trick of the dawn. And maybe, if this era is what many suspect, one of them will turn out to be a Mercury, a missing rule, the corner of a deeper physics showing through the wallpaper. Whichever way each one falls, notice what never happens. The universe doesn't get smaller or more ordinary or finished. In 2 centuries of impossible things, the answer has never once been that the sky owed us an apology. The books just keep getting thicker and stranger and closer to true. So let's end where all of this is actually happening, which is right above you tonight. While you've been listening, the telescope has been working. It's up there now, 1,000,000 miles out on the midnight side of the world, roughly in the direction your ceiling is pointing, 4 times farther than the moon. It isn't sweeping or searching. It's holding still, golden face open to one small scrap of dark, the bucket out in the slow rain of ancient light. Drop by drop, the photons are arriving, and think about what each one is. A traveler that left a galaxy before Earth had oceans, that crossed 13 billion years of growing, stretching space, thinning into gentle warmth along the way, to end its entire journey tonight, softly, on a cold gold mirror the size of a bedroom wall. The telescope catches it, and counts it, and waits for the next. It never gets impatient. It can't come home, and it doesn't need to, because its harvest is light, and light posts itself. Sometime before morning, a great dish antenna in a desert somewhere will turn to face it, and the night's gathered darkness will stream down as numbers, and somewhere in those numbers, quite possibly, is the next impossible thing, riding quietly toward a screen nobody has opened yet. The screens live in an old brick institute in Baltimore, where the telescope's schedule is kept. And there's something pleasingly homely about that end of the operation. A machine of gold and genius, parked 1,000,000 miles into the dark, takes its orders from a building with radiators and a lobby where somebody is on shift right now with a cup of coffee going cold beside the keyboards. The world's astronomers apply for the telescope's time the way people apply for anything, with forms and deadlines and long odds, and the winning stars get woven into a queue that runs day and night, years deep. Which means that scattered across the dark side of the planet tonight are scientists in every time zone who know their turn is coming. A graduate student somewhere is checking a download page again before bed because the frames they waited 3 years for arrive sometime before breakfast. An astronomer on the far side of the world is falling asleep the way a child does before a birthday. Somebody's little patch of sky, somebody's faint red dot, somebody's answer or beautiful new problem is coming down through the big antennas while they dream. The golden eye doesn't know any of this, of course. It just stares and gathers and posts the light home. But it's nice to remember, as you drift, that its every picture lands eventually in a warm room in front of a person who has been waiting for it the way you'd wait for a letter that took 13 billion years to arrive. And your room, if you think about it, is the last instrument in tonight's chain. Every fact in this episode ran the same relay to reach you. 13 billion years of flight. A few seconds on a golden mirror. A night in the antennas and the humming computers. A while in the warm brick building with the radiators. A season in the journals and the arguments. And then tonight, the last leg, a voice in a dark room, arriving at a listener with their eyes closed. You're the final destination of light that left before the sun existed. Not a scientist on shift, not a screen in Baltimore. You, under the covers, breathing slower than you were an hour ago. There's no obligation that comes with that, which is the nicest part. The little red dots don't need you to solve them. The fog doesn't need auditing tonight, and the 2 stubborn speedometer numbers will hold their argument perfectly well without a referee until morning. Everything in the album keeps without you. That's what it means that the light is old. Nothing out there is in a hurry. Nothing out there has ever been in a hurry. And the impossible things have the longest patience of all. So you can do what the telescope does between targets. Nothing. Drift on the loop. Hold no aim at all. The universe spent 13 billion years getting this story to your bedside, and it would consider the delivery a complete success if the ending put you to sleep. Here's a last small difference between you and the telescope, and it's a kind one to end on. Tomorrow morning your night will end. Light will come up in the curtains, the room will reassemble itself, and the sky that held all of tonight's impossible things will go modestly blue and pretend to be a ceiling again. The telescope has no mornings. It lives in one continuous night. Years long, decades long, parked where the sun never crosses its face, its sails holding the one shadow that never moves. It gave up sunrises entirely, forever, so that its stare would never have to stop, and there's a fair trade hiding in that. The golden eye keeps the permanent night so that yours doesn't have to be permanent. You get the mornings. You get the blue ceiling and the kettle and the ordinary day, and all night, every night, the deep keeps being watched anyway, by something that never needs to be relieved of duty. Astronomy has always worked like that, someone awake on the hill so the town can sleep. It's just that the hill is 1,000,000 miles high now, and the watcher on it is golden, and patient beyond any living thing, and it will still be staring, catching the old light drop by drop. Long after tonight's episode is something neither of us quite remembers. The town sleeps, the watcher watches. That's the arrangement, and tonight it holds. And if sleep is still circling the bed, give it something to carry. Count the impossible things. Slowly, the way you'd count sheep, grown galaxies on the first page of the album, finished before the universe was properly begun. Hundreds of little red faces that no one in the family can name. Black holes heavier than their own galaxies. Newborns outweighing the household. Spiral arms combed smooth ages before the universe learned to be calm. Retired galaxies at the dawn, their stars settling like embers. Ash that arrived before the fire. A first morning with too much light in it, and fog that lingered anyway. One number, measured two careful ways, that refuses to agree with itself. 40 pairs of worlds in Orion, with no sun and each other. One cold visitor, breathing its strange breath, already gone. A starless night, millions of years long, quietly assembling everything in the dark. And a small, scarred golden mirror, holding perfectly still through all of it, catching the patient proof of everything. Drop by gentle drop. Count them without solving them. Nobody's solving them tonight. That's the loveliest part. You can set the whole album down, because here's the gentlest fact in the whole night. None of these things are new. The grown galaxies finished growing 13 billion years before you were born. The red dots lit and faded before the sun existed. The couples in Orion have been falling together since before your grandparents danced. Nothing in the universe changed this year. Only our eyesight did. All the impossible was already there. Patient in the dark, the whole time. Waiting for someone to build an eye good enough to be surprised. And the eye has decades of cold and stillness left in it. The surprises will keep arriving on schedule, page after page. And not one of them will ever need you to wait up. So close the observatory down for the night, gently. Your eyes have done their shift. Let them fall shut the way the big shutters close on mountaintops at dawn, slow and sure. Nothing hurried. The watching is handled. A golden eye that never blinks is minding the deep for you, holding stiller than any sleeper, out where it's always quiet and always night. You can forget every galaxy and golden hexagon by morning. Forget the dots and the fog and the arithmetic, all of it. The sky will keep the notes. The album will keep arriving. And if the universe should get caught doing one more impossible thing while you're asleep, it will keep until breakfast. Impossible things are very patient. They've already waited billions of years for us, and they'll wait one more night for you. Let your breathing slow down to telescope speed now, long and even, gathering the dark drop by drop. There's nothing left to hold up. The universe is holding itself, the way it always has, whether or not anybody understands it yet. If you're still awake and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, stay just as you are, warm under the covers, while the gold mirror out past the moon keeps its long, calm watch over a universe that is still, wonderfully, stranger than its books. The stars will keep spinning while you sleep. Good night.